Greetings, I'm Afrina Ikwan.
Hello, my name is Sophie. My name is Anis Iliani and I will be...
Hi, my name is Alisa.
Hi, I'm Akma.
The Xilto underwater vehicle, inspired by Ocean Gate Titan submarine, aimed to revolutionize undersea research by utilizing a pump jet propulsion system. The vehicle, designed to withstand the rigors of the ocean depth, has undergone extensive testing to ensure optimal performance and maneuverability. The vehicle is powered by a hydro pump jet utilizing a water vacuum to force water through the pump and nozzle. In case of mechanical failure, the vehicle also have a propeller and transducer for safety. The Xilto project defies traditional wisdom, combining technological innovation and scientific investigation, potentially altering our understanding of the ocean and inspired future explorer.
Problem Statement 1. The issues regarding the submarines. Submarines can be quite complex to navigate, requiring extensive training and technical expertise. Underwater vehicle, however, can be piloted by any individuals, allowing easier access to underwater exploration and observation for a broader audience. Other than that, environmental concerns also comes into play, as submarines, like all vessels, produce waste and emissions that can impact the marine ecosystems. While modern submarines are designed to minimize their environmental footprint, the disposal of wastewater and the potential for accidents or fuel spills remain areas of concern. Problem Statement 2. Traveling with the risk of flight disruptions due to extreme weather events and winds. Aircrafts like planes, jets, and helicopters are susceptible to weather-related disruptions, such as storms, fogs, or strong winds. Underwater vehicles are less affected by atmospheric conditions. As for the ocean, the weather will not affect it if we travel underwater. The giant wave obstacles can be avoided, while flight disruptions can sometimes compromise passenger safety. Underwater vehicle can navigate through bodies of water such as oceans, seas, rivers, and lakes. This diverse range of routes provides flexibility in traveling options, allowing passengers to bypass areas affected by flight disruptions or congested in air traffic. Problem Statement 3. Overcoming technical issues regarding existing research mediums. Visibility often relies on basic lighting and cameras that may not perform well in turbulent or low-light conditions. By having our project, scientists can see the ocean with their own eyes. High-resolution imaging technology by using sonar transducer and the camera in the vehicle directly close to the thing experimented in the ocean itself. This could enhance visibility and allowing for clearer data collection in all water conditions. Standard vehicles may not have sufficient thermal protection, affecting their operational efficiency in extreme temperatures. As for Xilto, having the strongest materials as its body can overcome the cold temperatures, expanding the range of environments that can be studied. Navigations can be limited by the terrain, and maneuverability in complex underwater environments can be challenging. Xilto is designed with an advanced propulsion and navigation systems, providing superior mobility and the ability to traverse divers from the difficult rocky underwater terrains. Combination of advanced materials, innovative designs, and cutting-edge technology ensures superior performance, making Xilto an indispensable tool for advancing oceanographic research.
For this project, the methodology integrates both qualitative and quantitative research methods to ensure a comprehensive and rigorous approach to developing Xilto. Now, let us move to how our research on Xilto works. To understand the varying conditions our underwater vehicle will face, first and foremost, let's explore the ocean temperatures and depth. In tropical seas, located at the equator, surface temperatures range from 25 Celsius to 30. Mid-latitude ocean is between 15 and 20. The polar regions receiving minimal direct sunlight have surface temperatures that can drop to -2. Deep ocean experience a significant temperature change in the thermocline layer between 200 meters and 1000 meter depth. Here, temperature drops rapidly, reaching about 4 Celsius in tropical waters before decreasing slowly due to higher water density below the thermocline. When designing our vehicle's hull, we must consider how steel reacts to these temperature changes. Steel can become brittle at lower temperatures, requiring us to use materials like YI416 steel. For a 10-meter diameter hull operating at 600 meters depth, we estimate a required thickness of 10.8 centimeters based on our calculation. Water pressure increased by 1 atmosphere every 10 meters. With a yield strength of 690 megapascal for YI416 steel, our design must incorporate a safety factor of 2.5 to 3 to ensure reliability under pressure. Thickness requirements increase with both depth and diameter. For example, smaller submarines require thinner hulls, while larger submarines need thicker hulls to withstand the pressure. Here is our calculation for 600 meter depth as well, and we get the estimation value close to the water temperature factor, which is 10.9 centimeters. Now we have the sonar. The sonar transducers will help Xilto navigate by emitting sound wave and detecting their echoes. Using frequency between 200 kHz and 500 kHz provide a good balance between range and resolution. To move, Xilto used the hydro pump jet as the main engine. The system starts by drawing water from the surrounding environment into the intake, which is the water vacuum for this case. Inside the pump, an impeller is like similar to a propeller but enclosed within a casing. The impeller will spin at high speed. As the impeller spins, it creates a low pressure area that pulls water into the pump and then accelerates it towards the diffuser. The diffuser slows down the water flow, which increases the pressure. The design of the diffuser ensures that the kinetic energy of the water is efficiently converted into pressure energy. The high pressure water is expelled through the nozzle at the rear of the system, propelling the vehicle forward. In case, if the engine suddenly fails to work, we have the emergency engine, which is the propeller. Xilto will operate likely at speeds between 2 and 5 knots. As for the energy source, we decide to not use fuel to protect the ocean and the underwater ecosystem, obviously. Therefore, we came across the usage of batteries and compared the sodium ion with the lithium ion. So, we find out that sodium ion batteries offer several advantages over lithium ion batteries, including lower cost, less environmental impact, increased safety, and fast charging times. This benefit makes sodium ion batteries a suitable choice for Xilto.
Assalamualaikum warahmatullahi wabarakatuh, and I'll be talking about the commercial viability of our underwater vehicle project. So given that the purpose of this underwater vehicle is to promote water transportation and underwater transportation and exploration, hence the company that I think would benefit a lot from this project would be tourism companies. This is because tourism companies that offers underwater activities such as scuba diving and even snorkeling, they can widen out their options by adding underwater exploration to it in a vehicle. Hence, people that have tourists that wants to explore the underwater without paying a lot or even without getting a license, they can do so with the existence of this underwater vehicle. In addition to that, disabled people also can enjoy the underwater, the beauty of the ocean without having to risk their life. Next, the company that I would think would benefit from this underwater vehicle will also be research and development companies such as Petronas, the oil and gas company. This is because they have a lot of oil rigs in the middle of the ocean, so of course they have to do a regular checkup for the safety of the structure of the oil rig and do maintenance activities, because this underwater vehicle is is easy to access and maneuver under the water.
To sum it all, Xilto approaches the sustainability to manage and protect marine and coastal ecosystem as stated in SDG 14 Life Below Water by equipping it with sensors and cameras to monitor marine ecosystem, collect data on water quality, and detect pollution or illegal activities. This helps in managing and protecting marine environmental by providing real-time monitoring and data collection capabilities. Not only that, by enabling detailed underwater research, Xilto can help scientists to study the effects of climate change, ocean currents, marine life, and underwater ecosystem. Understanding these impacts better in SDG 13, Climate Change Action and Strategies for Mitigation and Adaptation. In a nutshell, the development of an underwater vehicle like Xilto can have significant impacts for achieving multiple SDGs by enhancing marine research and protection, promoting sustainable technological innovation, and climate change initiatives. By targeting these goals, our project can contribute to global efforts in sustainability and environmental conservation.